Welcome to the What's New in Geographic Calculator webinar. We're going to talk about our new release, the Geographic Calculator Cloud, a browser-based application containing the most often used features within Geographic Calculator desktop software, which has also been updated to version 2025, and we'll touch on that a little bit today as well. My name is Scott Weber. I'm the product manager for Geographic Calculator, and I'm with Sam Knight, who is the Vice President of Product Management. The webinar format today, you'll be in listen-only mode. Please use the question panel with any questions that come up, and we hope you do have some. We'll try and answer them along the way if possible. And the session is being recorded and should be available on our YouTube channel within a few days. And here's some information about the YouTube channel with the QR code. And I'll let Sam talk a little bit here.
Okay, so we do have some upcoming training opportunities of a few different varieties. We are currently in the midst of a Global Mapper public online course. These are all online courses. We are also beginning to offer in-person training as well occasionally. If you check out our website, you'll see some of those opportunities listed. And I want to note one thing here on the training opportunities that we see upcoming for Global Mapper. You'll see the first three courses listed there: geospatial analysis, terrain analysis, and LiDAR processing, all in Global Mapper. And then you see what is simply called Global Mapper training and LiDAR processing training. So for 2024, we were trying a new format and making it a little more granular for folks. And basically, by popular request, we're going back to our old formatting. So it's going to be the two grouping there: Global Mapper training and LiDAR processing training. Encompasses all the same things that we've been doing in a group of three this year, but it's just simply grouped maybe in a way that folks are a little more comfortable with understanding. Then down at the bottom there, if you'd like to join us for Applied Geodesy and Geographic Calculator training, that's going to be coming up again in February. We just did our fall course in there. So if you'd like to join me in February for Applied Geodesy, you're more than welcome to sign up for those courses as well. Okay.
There we go.
So our annual online conference, GeoTalks, is coming back up. This is a conference that we host every year in January. We've been doing this for a number of years now. It's basically a full day of very interesting sessions related to everything we do here at Blue Marble. So you'll find speakers talking about both Global Mapper Suite type products that they're creating, all varieties of map data, map analysis, different applications there, as well as things more on the geodetic side of Geographic Calculator that we're here to talk about today. And as well, it's coming back around on our annual academic scholarship. So students at accredited institutions are eligible to apply for our academic scholarship, which is both a scholarship and a perpetual seat of Global Mapper software itself. The deadline for that is coming up in just under a month in December. And if you go to our website, you'll find all the information about how to submit that. The URL is at the bottom of the screen. You can also find that under academic programs on our website under the resources dropdown of the toolbar there.
Thanks, Sam. So let's look at some general updates for Geographic Calculator. These apply to both the desktop software as well as the cloud application. And two of the key features are support for EPSG latest version 11.017. And this is the basic geodetic engine that we use to drive our GeoCalc, which is the underlying geodetic part of Geographic Calculator that you see from the user perspective. And all the latest definitions that EPSG, it's kind of the gold standard in definitions in the industry. We keep up with those and we are up to date. And we've also updated the National Geodetic Survey's horizontal time-dependent positioning system HTTP to version 3.5.0. And the big feature in that is that they've added ITRF 2020 to the mix. And so we are now up to date with that. Now in the desktop software, we're going to talk about desktop briefly here. We've put most of our development effort into this new cloud product. So that's going to be the feature of this webinar. So we'll talk about desktop first so that we don't lose track of it and throwing it in at the end. So we have over 50 fixes to existing features and 25 new features and improvements that we've worked on for version 2025. And I'm going to now go to live. So here's the desktop software. Many of you may be familiar with it. If you're not, this is the interface. On the left, we have the project manager, and Sam has a whole bunch of what we call jobs set up here of various types. And when you start up, you get a job guide. You can click along here and it tells you a little bit of information about the 13 different types of jobs that Geographic Calculator Desktop can do. It tells you what sort of input files and what sort of output files you can use in each of the different sorts of jobs. Over on the left are the actual jobs themselves. Here's an interactive conversion job. You enter one input point manually, and you can either convert, reproject, change units, or transform a datum transformation to a different system, and you get the output on the other side. The interactive job is actually interesting because you can change the direction of the job, right to left, left to right. You can also do forward and inverse conversions. So that is like you enter an input point and you can then enter an azimuth and a distance, and it will tell you what coordinate position you end up at. And an inverse is just the inverse of that, where you have 2 points and it will tell you the azimuth and distance between those 2 points. This job is available in the cloud product, which we'll get to briefly. So one of the things I wanted to show you here in the desktop software is that HTDP, the horizontal time dependent positioning update that we've done. And so here we have ITRF 2020 entered for the source coordinate system and NAD83 2011 as the target. We've entered a point here in the main area, 44 degrees north, 70 degrees west, and double clicking in the coordinate transformation box. You can see I have time dependent transformations. I'm going to double click and it's going to fill the box with it builds on the fly the correct HTDP transformation that works between ITRF 2020 and NAD83 2011. And one very important thing that I forgot to mention is that this is time dependent, so we do have dates involved. And in this case, we've got January 1st, 2014 as a source and a different date, January 1st, 2008 on the target. HTDP does allow you to enter different dates for source and target. That is not true of every type of time-dependent coordinate transformation. We get a lot of questions about the 14 parameter, sometimes also known as 15 parameter time-dependent transformations. Those require the same date to be entered on the source and target. And the reason for that, I'll just go ahead and go into it since I went down this road. One of the parameters of a 14 parameter transformation, that 15th parameter, is a reference date. And so the two dates involved in the time, one is the reference date that's the parameter of the transformation, and the other one is the date that you enter in the interface. We require you to enter the same date on both sides. That way there's no confusion about which date is the one actually being used. So a little bit of an aside there, but useful information for those of you that they're very common. There are a lot of 14 parameter transformations out there now. So keep that in mind that that's how those work.
Yep, there's certainly been a lot of people asking for ITRF 2020 and HTTP, so that's a good update to have folks be aware of.
Yeah, so I took a little aside there, but I think that was useful. We get that question a lot in tech support. So back to HTTP, where we have different dates for source and target. Then I'm going to click calculate, and we can see that we get a different coordinate on the output target side from what we entered. But the point here is that ITRF 2020 is now included in HTTP, and it was not in the earlier version. Let's just review that in the desktop version of the software, we can do these interactive conversions. We can do point database conversions, we call them. And basically is spreadsheet related. Tabular data can be entered, and you can work on a whole sheet of data as long as the columns are consistent. There's a forward and inverse version of the point database style, just like I had described before what forward and inverse are. There's something called best fit. That's where you can enter some control data where you have it in a local grid and a known coordinate system, and we can fit a coordinate system between those two that you can then reuse for any data that you have in the local grid that you want to convert out to some known system. Seismic survey conversion, very popular job. We can handle a variety of seismic formats, SEG-P1, P111, UCOA P190, and a few other formats. Vector data conversion, that is one of the jobs that is available in the cloud version that we'll get to in a moment. So shape files, DWG CAD files, those sorts of things. And then raster transforms is one of the other big ones. Wide variety of raster formats that we support. There are a few specialty jobs like area calculation, line intersection. Let's see, what else do we have? I think that hits most of the important jobs that the desktop software covers. And we took the three most important jobs from desktop. That's the interactive conversion, which we now call in the cloud version, we're just calling it point. The point database spreadsheet type file, which we call point file in the cloud version. And then finally, the third one that we have at this point is the vector data conversion, which we call vector file. Raster transform is coming soon. So keep your eyes peeled for that to be available in cloud at some point in the fairly near future. So let's take a look at Calculator Cloud. So here's the interface, and we have three tabs across the top, point file, and vector file, as I just described. There are some settings that we can access to do things like turn time dependence on and off, change the ordering of northing and easting, and various things like that. The interface is similar to the desktop, but we've shrunk it down to a two-column layout. Instead of having the coordinate transformation box in the middle, it is now in the lower left. And the reason for that, we can resize this, and it fairly nicely resizes for different formats. And we're going to get to that in just a second when we look at the features of this application. But it's got some versatility for fitting tablets, even some phones. Not a mobile version yet, but it will work on certain phones as long as you have the right Android version or iOS version. So we'll be improving that in the future, but you can see that it stacks as you narrow the window. So pretty handy if you're out in the field. So speaking of the field, let's go back to our slideshow for a moment. What have I done, Sam?
Stuck behind our meeting controls there.
Thank you. Okay, so let's look at the key features of Geographic Calculator Cloud. I'm one slide too far, sorry. There we go. Use wherever you have an internet connection. So you're not tied to your desktop. You don't have to have your IT department come and install the desktop software on your desktop computer and then use it from there, or even a laptop. If you've got an internet connection, you can enter your order number and you're off and running with the cloud application. We have this concept of teams. So if you are an enterprise customer and you have several seats of Geographic Calculator on your order, then you can use those in a team setting. And we're going to talk about the credit system of usage in a moment. But you can share the credits among the users on an order. So if you have 10 seats, 10 people can go to this application and be using it. If an 11th one comes along, it'll just tell them that the seats are all used. But any device, anywhere, if you got an internet connection, the team can access the software. So there are three calculators. We've already talked about this: the point, individual points, spreadsheets, the point file job, and vector files in vector. There's also a nice search function. We'll take a look at that in a little bit. We can search the data, what we call the data source. It's our database of geodetic definitions, and we can search them by name, by EPSG code or other codes, by location. You can draw a box or place a point on a map and filter by the intersection of that bounding box or containing that point to filter what objects will show up. You can filter by object type. Maybe you only want to look at transformations, or maybe you only want to look at projected coordinate systems. And then finally, if you find a definition of interest, you can view and copy the well-known text or GML definitions out to a separate file to transfer to other software. The point file job accesses files from local storage. The vector file can work from local storage or from Azure Cloud Storage. And we have three classes of virtual machines, and those are the machine is selected based on the input file size. Now, how do you get access to the Geographic Calculator Cloud? Well, right now it's tied to a Geographic Calculator desktop order. With your Geographic Calculator desktop order, you get 100 free cloud credits per month. And what is a credit worth? Okay, well, it's very complicated. Cloud processing is made up of bandwidth, upload and download, the actual processing on the virtual machine, and a number of other facets of the whole cloud process. And so you can think of 100 credits is good for processing this very generally. If you have a typical GIS file, you could do 100 files on 100 credits, probably about 4 gigabytes of data processed. Those are very, very broad numbers based on our testing of some average files. So your usage may vary depending on if you do a lot of large files. Obviously, it's going to be a smaller number of files. If you do a lot of just point conversions, then you're going to be able to do more than if you're processing large vector files, LiDAR files, for instance. In addition to the 100 free credits you get with your Geographic Calculator desktop order, there are annual plans with 250 or 500 credits per month also available. You can do a 2-week evaluation. And to do that, you simply go to the application website, register as a Blue Marble user. There's a register button right on there. And then there'll be a button to request the trial right up at the top and prominently displayed. And that will set you up for a 2-week trial. And for more information on any of these tiers of the free versus 250 versus 500, please contact sales@bluemarblegeo.com for information on all of that. Sorry. And so back to the application. So we have the source coordinate system box, just like we do in the desktop application. In this case, it happens to be filled in with NAD 83, UTM zone 19 north, and we have a target coordinate system, which is NAD 83. So the way it's set up right now, we can do a transformation, and I'm going to enter just a very, very, very generic coordinate in here. And those values in meters should land me in the middle of whatever UTM zone I happen to be in, 19 north. And I can click process. And all we've done here is a conversion. We've taken a UTM coordinate in meters and we've converted it into latitude and longitude. We've done no datum shift, no datum transformation involved here. So that's the most simple sort of conversion one can do. To make things a little more interesting then, let's change datums to WGS 84. So now a datum transformation is going to be required. And so I'm going to click on my transformation box. And I have a number of choices. And I will select this NADCON transformation. That's a grid-based transformation from NGS. And let's see what we get. So I'm getting the same result as I got before. So I'm guessing that transformation I selected is actually
So what you did there was
I got a zero shift transformation. Yep. I can see that. Yeah. There we go. I picked a zero shift transformation instead of the NADCON that I intended to. So now we can see in the process manager, it'll show us each process we've accumulated until we can clear those out at any time we want. And so what I wanted to see was a slight difference in the result using a datum transformation. Let's do something a little more interesting. I'm going to start from the North American datum of 1927. Oops. And I'm going to go to the North American datum of 83, the most recent realization of that. I think if I just type 2011 here, that should filter me. Oh, I know what's wrong here. I have a coordinate in here that's sort of a silly coordinate. I'm going to clear that out. And now I'll try that again. By default, the target coordinate system is filtered by any coordinate that's entered in the box. There we go. And there's what I'm looking for, NAD 83 2011. Saved me having a few clicks down the tree. We'll just enter a coordinate in Maine again. I'm going to clear out my process manager. So I'm changing datums here, so I do need a coordinate system. And I have a few options here, but notice we have NADCON 5 here, so that's worth mentioning. NADCON 5 is the latest standard for from the Geodetic Survey in the United States for transformations. And we do support that. And what's worthy of note here is if I select this, we're going to see that the way NADCON 5 works is it concatenates each step. It's going to start from NAD 27, and there's a transformation grid that takes you just to the next realization of the North American datum, which would be the NAD 83, the original from 1986. And then we're going to go from the 1986 to the next one, which is HARN. And then from HARN to FBN to NSRS 2007, and then finally to 2011. So it's a 5-step process, and we're able to concatenate all 5 of those together automatically. So we do support this tool, and that's kind of a special thing that we offer. Another thing that with NADCON 5, there are uncertainty values. Instead of having an uncertainty or an accuracy value, as it was sort of traditionally called, for the entire area of use, NADCON 5 offers what they now call uncertainties that are based on the location within the grid. So it varies across the United States. And so for this particular location, we now list out what those uncertainties are. And so there's a 0.62 meter uncertainty north-south and 0.67 east-west for this particular location. If I enter a different location, I'll get different uncertainties. So that's an interesting feature with NADCON 5. And that's becoming more of a thing, to have uncertainties that are grid-based, and that we're going to see that more and more with certain types of transformation files where uncertainty is included and specific, location specific, we could say.
So Scott, we've done a few things now. I see some drop downs on some of our parameter dialogues. What are those drop downs indicating for us?
You mean these?
Yeah, right there.
Here? Yeah, so this is a recents list. So as I work with the software, each system that I've selected, in this case, these are coordinate systems in this box, it stores them up for quick access later. Likewise, any units I've selected, of course, I've only been in degrees here, but any of these data boxes that you access, a recents list will accumulate, I think up to like 15, and then they roll off. We have information, so I can very quickly access the information on the North American datum of 1927. I can see what its identifiers are in various pieces of software. The area of use, remarks, information about the underlying datum, its identifiers, and so on, and we can work our way down. There's the ellipsoid and the prime meridian on which it's all based. So quickly available there with an information button that's a little more easily accessible than in the desktop software. Notice we've color coded some of the boxes to help guide your eye to what's important. That's a nice new feature. It's a web-based interface that uses modern controls to just give it a modern, better, nicer look. Okay, so we've looked at the point tab or job. So let's move on to the point file. And here you can simply click open, load a file, enter the number of header rows. If you forget to do that, you can quickly reload the file. And here is our data grid, similar looking to desktop, but now instead of having drop downs down below the grid, they're right in the headers. And so if I want to make X my longitude, I'm sorry, it's not longitude, it's I'm looking here, I can see that they're UTM values. Let's see, do I have a, yeah, right there. So I've already got net 83 UTM zone 19 north in my recents list, so that made it quick to select. Now that's going to change the names here, so I can tell by the values that that's my northing in the, no, sorry, obviously easting is X, northing is Y. These values are in the millions, these are in the hundreds of thousands, so that makes sense for UTM. And then I'm going to add some columns for the output down here on the end with my plus button. And our target coordinate system is set to net 83 2011, so that's going to be latitudes and longitudes. So I'll say output geodetic latitude, add another column, output longitude, and then I need a transformation. And I can select NADCON 5 again. It should be ready to process. And if we keep an eye on these two columns out here on the right, they are now filled in with the latitude and longitude. We did a datum transformation, and we also changed the unit we went from projected. So we did a conversion from projected to geodetic latitude and longitude. And then our final job in the cloud application is the vector file job. And one thing I should note is that as you move from tab to tab, it keeps the source and target coordinate systems and transformations that you had previously used in other tabs. And so if I switch from point to vector, you're going to see the same information there. So they can be reused. A lot of times you might check a point in the point tab, and then when things look good, you're ready to do a spreadsheet or a vector file. So instead of having to enter those source and target coordinate systems and transformations over and over again, if you happen to be doing a workflow that takes you through several, a check and then a process where you don't have to change those, you don't have to enter them again. Now, when I load a vector file, it may come in with its own projection information, and that's exactly what's going to happen here. We're going to select a file called main towns. Now, notice I have to select all the files that are associated. This is a shape file, but a shape file has a DBF and a PRJ and an SHX and so on associated with it. For security purposes, we have to select these individually. Takes a little getting used to, but it's something that we have to do for security reasons. And let's see here. that again. There we go. I think that was me, not the application, that had a glitch there. So we can see that we've loaded the shape file. It has 1,085 features, and it happens to be in NAD 83 UTM zone 19 north, which I believe we were already set at, but it would have filled that in automatically from the PRJ information. And then, like before, we can, since we're set at NAD 83 2011 on output, we'll leave that the same. We go back and select our NADCON 5. It did clear out the transformation when it read the PRJ and refilled in that source information. And I can process that file. And when it's done, it downloads a zip file to my downloads folder. Speaking of downloads and uploads, in the vector file job, we have the choice of local files, which is what we just did, or cloud storage. And if we click the open button while cloud storage is selected, we're going to see two choices. You can enter a SAS link or an account name and key. And these will link you to Azure Cloud Storage, your own Azure Cloud Storage accounts. Keep an eye out for access to AWS or Google in the future. But right now it works with Azure. And so that covers the 3 jobs. And I apologize, I'm a terrible driver. There we go. I'm not going to go over this summary slide. We've just talked about all these things, but you can see, remember, most importantly, anywhere you've got an internet connection, you can use this application. You do need Geographic Calculator desktop license in order to access the application at this point in time. And again, contact sales@bluemarblegeo.com for further information on setting this up or purchasing one of those bigger credit plans. I just want to remind you that this session was recorded and will be available on our YouTube channel in a few days. And so we're ready to answer some questions. So please use the question panel. And we've had a few come in here. So we'll take a look at those, but we have time for some more.
Okay,
what do you got, Sam?
Yeah, so we got a few questions here. So the first question we've got is how does the credit sharing work among those users on a enterprise plan?
Okay, I talked about that a little bit, but I'll go over that in a little better detail. So if you have a Geographic Calculator desktop order that has a certain number of seats, a number greater than 1, which would be typical for an enterprise order. Now, a large enterprise might have multiple orders for, say, different regions where they have offices. So if there's 10 seats, if let's say an enterprise has 3 offices and each office has an order with 10 seats, then each one of those offices would be a team, and up to 10 users could log in. If they have the order number for that office, they log in and they will take one of those seats. Now, in a different region, that same enterprise has a different order for that region. They're a team and they would access theirs individually. And again, if there's 10 seats and user 11 comes along and enters the order number, it'll kindly tell you that all the seats are taken, and you can talk to your peers about gaining access if you need a seat. The way that the credits are shared is it's a pool, and there's no individual allocations within the team. So if you have 500 credits on a team of 10, it is possible for one user to consume more credits than 1/10. It is just a pool available to everyone in that team. So, on a first come, first serve sort of basis.
All right, that makes sense. Um, Then a couple other, I think we have two questions here that are fairly related about some of the coordinate systems. I think we get this question just about every time we do a calculator webinar. Is the acronym for all the folks out here, NATRF, what's known as NatRef, is NatRef in Calculator Cloud?
NatRef is not in Calculator Cloud yet because it has not been officially released by the Geodetic Survey at this point. We are prepared for when it comes out. So, for example, and this may be another question that people are interested in, but there are the new state plane systems, the NSRS 2022 state plane coordinate systems coming along. Those will be based on NatRef 2022 as their base datum for those projections. So NatRef hasn't been officially released. So right now, the NGS has an alpha version of those state plane coordinate systems based on ITRF 2020. And that'll just be substituted in, NatRef will be substituted in there when the time is ready, when they're ready. And we'll talk about the timing on that in just a second. So we've actually already imported the alpha version of the state plane NSRS 2022 systems, which there's almost 1,000 of them, into Geographic Calculator successfully and worked with them, sort of a proof of concept that's going to work just fine for us. So the timing of this, the rollout, of course, it's all called 2022, so we're a few years behind schedule. The pandemic slowed things up, and some other technical considerations. The latest information that came out about a month ago was that these things should be rolling out during the course of 2025. There's a process where they go into a beta state, and then they are released, people try them, feedback is gathered, and then they will finally be approved. And we're hoping that by the end of 2025, these things will be official. We will not have them in Geographic Calculator until they're officially released by NGS. And Sam, maybe you might want to follow up on that if I've left anything out.
That pretty much covers it. We've had this is a fairly steady question that we've been getting for probably the last 5 to 10 years of when these are coming along. It's a very long-term project by NGS. A lot of folks are concerned with these new systems when they're going to come, but we'll be ready. Just like Scott was saying, it's ready now. We've done a lot of work making sure that both versions of the calculator now, our desktop and the cloud platform, are ready to receive these as soon as we get the green light from the authorities and they're officially published. So it's going to be an exciting year when those do finally come along.
Yeah, and in addition to that, the coordinate transformations, the Euler pole parameter rotational transformations, those parameters are out in an alpha state, and we're in the process of implementing those. And then there is what used to be called the intra-frame velocity models, and they've changed it to I can't remember the new acronym, so pardon me, but the velocity models for the intra-frame when there's tectonic activity and deformations that go on besides the large scale rotations, those transformations are still in the works as well. And we're in close contact with NGS, and we'll be implementing those as soon as there's information available to do so.
Okay, let's see here. We just had another question come in. When we were talking about the search tools that reminded some folks here about the GeoCalc Online. And so what does Geographic Calculator Cloud mean for GeoCalc Online?
That's a good question. So we had a tool called, well, we have a tool called GeoCalc Online. It had an interactive user interface that contained just a point-to-point calculator, like just the point tab in the new cloud tool. And so that has been retired as of the release of Calculator Cloud. However, there is the search functionality that was in GeoCalc Online has in large part just been borrowed and put into the cloud product. And I showed you an information dialog from the interface. There we go. There is a search tool that looks like this. So it's a nice interactive search tool. So if you want to browse through the database of geodetic definitions, there are some handy tools to help you do that. You can filter by object type. You can filter by names, remarks, codes, and so on. And then of course you just type in here what you're interested in.
Oop, you got the wrong. You need to select the box above it to actually type.
Oh, there we go.
There you go.
Yeah. And this is going to be a pretty broad search. But everything that contains net83 sorted by object type here. And so why is NAD27 in the list for NAD83? Well, it's probably because the remark in NAD27 says superseded by NAD83.
So these are all going to be very familiar controls to anybody that has been a user of GeoCalc Online in the last several years. You'll simply recognize all the actions with a slightly refreshed interface.
And here are the actions for downloading, for grabbing the definitions and copying them into a document for use elsewhere. So this search tool is a nice improvement over the search abilities within the desktop software, really. It's a much nicer user interface. You've got a map that you can, if I click contains location, I can click a point somewhere, and that's going to then filter anything I search on. I can do intersects the bounds and enter the coordinates of a box. I've got a geolocate button that.
You're getting a prompt over here.
Oh, sorry. There we go. So I hit geolocate, it takes me to Maine. And trying to figure out how to.
Yep, you've got your coordinates over there.
Oh, there's my box. Okay. I was having trouble getting that box started. So I can draw a box, it puts the coordinates over here, or I can type the coordinates in the box, and that will be, again, be a filter for any search that I do.
Okay, and there's a quick follow on there. Some folks are familiar with GeoCalc Online's previous connection to the Global Mapper desktop software for doing those lookups of online coordinates. And so that is basically unchanged. So if you have Global Mapper desktop software and you're trying to look up a coordinate system that's in the EPSG database that you don't have, that lookup works exactly the same way. It's just tying into our new database here.
One additional thing I should comment about GeoCalc Online is that if you're a user of the desktop software, if your data source becomes out of date just through time, there is a tool in here under import objects from GeoCalc Online registry. That is not going away because that API RESTful interface, whatever it is. If that doesn't mean anything to you, that's fine. But there's a location where the desktop software can reach out and grab the latest version of the GeoCalc online registry, so that your desktop software can stay up to date even as as the year progresses and new versions of EPSG come out. We update those. This is where you can very easily do the update from. And that is staying intact, so that GeoCalc Online will live on in that one way.
Okay, I think that wraps up the questions that we've had come in. We've had some great questions here, so thanks for being attentive and saving your questions for us.
All right, well, thank you for attending today. Connect with us on social media. We have all those links there. And if you have any additional questions, you can contact tech support at geohelp@bluemarblegeo.com. And we'll be happy to answer any further questions. So thanks for joining today. Have a great day.